Okay, let's see what we have here. So we start with a benzonitrile, add hydrochloric acid, water, and heat it up. Oh, this is acid catalyzed hydrolysis. Right, add some acid, right, and then water. That's hydrolysis for sure. Right, and heat it up to speed up the reaction. And hydrolysis of amide, of course, gives you a carboxylic acid. Okay, the nitrogen comes off as an amine, right? But amine under acidic condition, you get ammonium ion. Next one is this one also hydrolysis is under basic condition, hydroxide attack. Right, you pass through amide get um, uh, hydrolyzed further, you get carboxylic acid. Okay, but now the carboxylic acid under basic condition, you're not going to get carboxylic acid, right? You get carboxylate. And the nitrogen that comes out as amine stay as an amine, not ammonium ion. This is in basic condition. Okay, do not protonate it. Next one, so this is totally the acid catalyzed hydrolysis for sure of amine. All right, so cut amine bond and you get an acid. And since we have this in acidic condition, so your amine that comes out become ammonium ion. Indeed, there's an esterification. So no, the ester, there's a reverse of esterification. So there's an acid catalyzed hydration. So cut ester bond, just like like in C. Same thing. This cut amine bond is a cut ester bond. Heat it up, speed up the reaction. You get an alcohol and a carboxylic acid. If some of you remember when we talk about this in like a naming nomenclature, ester is made from half carboxylic acid, half alcohol. That's what you get. Okay. All right, let's move to C. Let's see what we got. An ester add Grignard reagent, so this guy will react twice. All right, so attack first time, you get negative charge at the top of more oxygen. Reform the double bond, kick out the methoxide. All right, you get a ketone, and ketone still reactive toward Grignard reagent. So go further. Here we go, and you get an alcohol. Do it twice. All right. The next one, LAH, exactly like Grignard reagent, but replace the phenyl ring with the hydride. Right, so hydride attack, but twice, same mechanism, you get an alcohol. Look at that similarity. So two phenyl rings, two hydride. Okay. Now dibol. What do you know about dibol? Well, it's a weaker version of lithium aluminum hydride. Right. That specifically for an ester, and you get it. What do you get? React one time. I know this is weaker reagent. React one time, you get an aldehyde. Okay. Don't forget to quench at the end too. Now, next one in H, so this is acid chloride. We have Gilman's reagent, and the other one is a long name, so it is a weaker lithium aluminum hydride reagent. Okay, so but these two are weaker version of their respective class of reagent, right? So there's a weaker version of lithium aluminum hydride, so react one time, all right? Oh, Tusky doesn't go away. Anyway, so the ethyl group will attack on that carbon right there, and you're gonna get a ketone. So react only one time and stop right there. This we have lithium aluminum tri-tert-butoxy hydride. So just like lithium aluminum hydride, but react twice, so you get an aldehyde version of it, like that. That's a pentyl ring, right? That's an aldehyde. Okay. All right, before we go, so summary. So summarize all reducing agent real quick. So there are two types of reducing agent. We have a strong and we have a weak. The strong one, a Grignard reagent, and lithium aluminum hydride. React with whatever you react with twice. Look like that, right? You get all the way to alcohol. The more selective one, the weaker one doesn't mean that bad. It's just more selective to aldehyde or ketone. Gilman's reagent can react with acid chloride. You get a ketone. Lithium aluminum tri-tert-butoxy hydride react with acid chloride, you get an aldehyde. So stop right there. Doesn't do like further reduction. We have another version of lithium aluminum hydride. So we have dibol, diisobutyl aluminum hydride. This one is for ester. Don't mix up. All right. So we have the tert-butoxide one is for acid chloride to aldehyde, but dibol is for ester to aldehyde. Okay. All right, we're going to go to synthesis strategy. Let's talk about it later, okay?